Hi, it's Jan Beta, and a while back I made a little video about this Commodore calculator from the 1970s, which is a pretty basic model, but it's a very nice LED display calculator from the 70s. And in that video I mentioned that I didn't have a more sophisticated model of Commodore's calculators. They also made scientific calculators. Shortly after that I got contacted by Gert, I hope I pronounced your name correctly, from the Netherlands, and he sent me a more sophisticated model that we're going to take a look at today. So this is what Gert sent me. Hi Jan, here's the calculator. I promised you I hope that you will have fun with it and that it deserves its place in your Commodore collection. It certainly will. I'm pretty chuffed about these calculators. Thank you so much for sending me another one for my collection. And I'm actually going to use these calculators from time to time. Success with your YouTube channel. I'm always watching it with interest. Thank you. I used to have some Atari 8-bit computers, which gave me a lot of pleasure at the time. Wishing you all the best. All the best to you too. And thank you so very much for sending me this calculator. So let's take it out of its box. We have this extra box here. By the way, this is very well packaged. You should always put a lot of padding into your parcels. Oh, this comes with the original AC power adapter. And this is the main attraction. Also comes with the manual and the leather pouch. That means business. And some Dutch newspapers from 2023. I'm going to read those later. So this is the original Commodore AC adapter Type 709C, made for the EU, it seems. So it has this European plug. And it's made in the UK. Oh, the irony. So output 6 volts, 200 milliamps. This is a calculator power supply with one of these plugs at the end. And yeah, it's totally serviceable. I think we're going to take a look inside. Of course, also comes with the manual, which is pretty cool. So let's quickly flick through this. Oh, trigonometry, keyboard layout, radius calculation. Yeah, and this is a way more sophisticated model than what I had previously. We can... That's actually a pretty concise manual for a calculator. That's cool. It has memory, 2 different memory banks, can do all kinds of more in-depth calculations. There's some scribblings in here from the previous owners. Back in the day, calculator was quite something, really, in the 70s. So, exponents, special applications, polar rectangular coordinates conversion. Wow, okay, this thing can do a lot. Oh, there's electrical impedance. There's also, of course, a section concerning electronics calculations. So this is actually going to be useful for me because I have no idea how to calculate many things. Appendix, International System of Units, letter symbols for quantities and units. This is quite cool, actually. So we have a rechargeable battery, which might be a problem. That might have leaked. We're going to have a look at that. Disposable battery model. Oh, I don't know if I have the disposable battery model or the rechargeable battery model. We're going to have a look at that shortly. Commodore Business Machines Incorporated, now defunct, unfortunately. As we all know, probably. And this is from the Minuteman 76 series. 76 is the year these were introduced, I believe. So, yeah, nice little logo, Minuteman. And here's the main attraction. This is actual leather, I believe. No, it's not actual leather. It's fake leather. Yeah, definitely fake. The pattern is printed and stamped on there. This is the SR6140R. So that's the rechargeable model, I think. Yeah. And there's Gert's name tag on there. And the label on the back is, unfortunately, quite worn away. So yeah, we're unfortunately not going to be able to reproduce this. But this seems to have been used by Gert for real. So no operation at this point, but lots more keys than the one we looked at last time. And this one still has the silver labeling, mostly because this is a label and not printed. This is just plastic and silver paint on there, and this has metal labels that are stuck on there. So yeah, I'm inclined to open this up and have a look if there's a battery that we have to remove and leakage and things like that. Seems to be 2 screws here. This is of course pretty bulky compared to today's calculators, but it's also 48 years old at this point. So let's carefully try to open this. I think the battery is removed already. That's good. There we go. Don't know where this was supposed to go. Don't know what this is. A battery? There's a bit of hot glue that's loose. Probably held the display in place, which is an LED display. And there's a lot more stuff going on in here than with the other calculator. These were actually Commodore made chips, and there are some Toshiba logic chips, or I think probably LED drivers that were separate. These chips were made in the 40th week of 1975, judging by the date codes. And there's actually a funny story about these chips, because these were ones that Commodore designed and ran in their MOS factory at the time, and these have the designator GHU, which actually stands for God help us. Because Jack Tramiel, the boss at Commodore, demanded of his staff at the time that they should manufacture these chips or design these chips in a very short time frame, and he ended the meeting that they had at the time with the words, God help you if you can't do it in time, or something like that. You can read about that in Leonard Tramiel's blog, actually, who wrote a little essay about these designators on the chips, which were like funny little anecdotes that the engineers had. And I believe Leonard actually programmed the logic in these chips. That was one of his things that he did at Commodore at the time. I think I am inclined to remove the whole circuit board from this casing. I believe probably this is where the battery went. I'm not quite sure what this is. Maybe that's kind of a charging circuit or something. I'm not sure. I'm going to take the whole thing apart, I guess. We need to replace those capacitors on here. That's definitely a good idea after all those years. And there's a bit of filtering going on here. So even if this power supply is not regulated, which I don't believe it is, probably just an unregulated linear transformer rectifier kind of job without a linear voltage regulator in it. This is going to do the smoothing and the regulation, I guess. Yeah, how to go about this? First of all, I'm going to put on my ESD safe wrist strap, and then we're going to have to remove this little socket here, I believe. Loosen this screw here a bit, so we can take this out. This is kind of a 2-layer board thing. There's one board here for the logic, and there's another board for the keyboard assembly. I think we should be able to pop the display out. This is not going to be easy. I'm going to be super careful. So this bends over like that. Oh, this is old school. And then we have this kind of dirty sheet of cardboard protecting this board here. So the whole keyboard assembly comes out with these little screws. I think I'm going to remove that too, to clean everything thoroughly. This looks way cool, actually. This is really, these are hand-drawn circuit boards, as you can see by the wiggly lines. No solder mask on this at that point, and all hand-drawn lines here. I'm going to take this out here, I think, so we can have a look at how the keyboard works, actually. Did I strip that? Oops. That is very unfortunate. Let's see if we can get it out. I totally stripped that screw. Yeah, I'm going to have to work on that for a bit. Let's remove the other ones. So that's what I'm dealing with here. That's completely stripped. Not sure how that happens, but I think this one is in really tight and I didn't pay enough attention. So things happened. We could Dremel a slot in it, or can try to use another little trick by using a rubber band. That might give us enough gription to turn this. So sometimes this trick works. You just use a rubber band of some description, put it on the screw, use the screwdriver through the rubber band basically, and sometimes that gives you enough grip to get this thing out. Nope. So that didn't work. So I'm just going to Dremel a little slot into the screw carefully. I'm going to mask off the surrounding areas so I don't damage anything. Let's see if we can get this screw out. Or if that doesn't work, I'm just going to leave the board in, obviously. Stop screwing around, I hear you say. Using some masking tape here. So in case I slip, I don't destroy the whole thing. Let's see if I can do anything here. We should probably do this from this direction. There we go. That should hopefully do. Let's see. So I basically just Dremeled a slot into this, and I'm now going to use a larger screwdriver, like a slot screwdriver, to get some grip on this. And there we go. Oof. Okay, that worked. Nice. This already is quite the adventure. Okay, the final screw. Okay, so we can remove this. And then we should be able to take the whole thing out here. Oh, there's springs. Oh, no wonder this was protected so well. This is quite a sophisticated mechanism, actually. Definitely don't want to mess with the springs here. Just going to clean the contacts a bit with the Q-tip carefully. This has like spring-loaded buttons. Each single one has a little spring, which is quite similar to the construction that the later computers that Commodore made had. And this is the circuit board. There's gold contacts for each and every button here. These have a silicon layer that is infused with carbon, so it's conductive. And when pushed down, these contacts close, and you have a kind of a matrix that closes the contacts and carries the signal to the chip, which then does all the calculations. And we have quite some dirt on the on-off switch, which this is, I believe. We're going to clean that with some contact cleaner and a Q-tip and do some general cleaning of the case here. I'm not going to take the whole thing out. I think I might put some contact cleaner on the gold contacts. It all looks really clean. And you can see here that our little window is red, just like with the other calculator. So I guess the reasonable order of operations is to do the soldering. I want to replace the two electrolytic capacitors that I can see on here. I'm going to do that first and then do some cleaning. There's some green spots here which I think are print, but I'm going to do general cleaning of the circuit board. There's some corrosion visible here, I think. Yeah, I'm going to replace the capacitors as my first step. And then I might even try to power this on and see what it actually does. This might be some kind of switch or something. It looks kind of original. It's definitely old. Not sure. It's a little too small for a battery. Even for a modern battery. So there are some spots here that look corroded, and this capacitor in particular looks a bit bulgy on the bottom. These older capacitors often didn't have like the little indentation on top where they're supposed to break. They often leak the electrolyte from the bottom once they leak, and this one seems to have done just that. So I'm going to remove the capacitors, do some cleaning here, and then put new capacitors in there. That's just standard values basically. This is a 33 microfarad one and this is a 47 microfarad one as far as I can tell from this perspective. But yeah, we're going to have to do some cleaning here. So yeah, there's some leakage there that we're going to have to clean off. That is Not so great. Ah, but it's just on the surface, I think. Just going to do what I can here with a bit of alcohol and a Q-tip. And thankfully there doesn't seem to be any battery corrosion on here. It's just from this capacitor, it looks like. And the traces are wide enough, so that shouldn't be any problem. Yeah, but first of all, let's put a new capacitor in there. This is a Europe Chemicon one, modern capacitor. Going to try to put it in there in the way the old one was. So bending it over, like so. Looking all right. And the other one. This one didn't leak, it seems. Just adding a bit more solder because it was that way. So, okay, let's remove our solder residue here. Both of these. And there's one trace here that I need to check. This one here. There looks to be a break in there. I'm just going to double check with the multimeter. So this should go from here to here. Oh, and it still does. Okay. It looks way worse than it is, it seems. So that's pretty much all I want to do to the circuit board, I think. Yeah, let's take a look at the power supply, I guess, before I try to plug this in. This has one screw missing already, this one here, which is always very trustworthy. So I'm just going to remove the other one. Let's see what this is. Ooh, okay, this is kind of nasty, of course. Okay, yeah, that looks awesome. This is a very crude power supply. So this might just be one of the crudest power supplies that I've ever seen, but it's actually not uncommon to have these in stuff from that era. 2 diodes, rectifier, and 1000 microfarad capacitor here. And there's a little fuse in here, I think, and that's it. Transformer, of course. Yeah, this is a very wonky construction. I'm not sure if I want to use this at all. Yeah, it's not very safe to use. This is not sufficiently attached. So I am inclined to just use this with my bench power supply for now. This is just a regular size phono plug, like this from my parts bin. And I'm just going to solder some random wires onto this and connect them to my bench power supply and set that up to 6 volts, I believe. Way safer and way cleaner voltage than from this slightly broken power supply. I might go in and fix this at some point because it's just such a nice piece to have. Just a very simple, unregulated power supply, but yeah, not really safe to use these days, especially not in the state it's in at the moment, and I kind of want to test the calculator. Just going to figure out the polarity. That goes to here, to here. That's a positive. Yeah, I think the tip is positive, judging by the fact that this is labeled plus here, and it goes from the positive side of this capacitor here. So I actually ended up plugging the original power supply in. Let's see if that outputs anything. Yeah, that's 9.6 volts. That is without a load, obviously. Maybe it's going down to 6 volts. But yeah, the tip of the plug is definitely the positive, as I thought from looking at the circuit board. I also found a replacement screw for this, so it's a bit safer to use. Yeah, tip is positive, so we're going to use the bench power supply with this, with some wires soldered on. Although the original power supply still seems to work. But yeah, probably not the best idea to use that in the longer term. And we have better options these days, thankfully. This is basically just an adapter for using some clips to connect it to my bench power supply. Just a workaround for now for testing. In order to test this, we of course need our keyboard because the on-off switch is on there. So I'm going to clean the contacts on here and on the other side and clean this case a bit. I'm just going to give all these contacts a little bit of a wipe with some alcohol and some contact cleaner. Might also use a pencil eraser here, I guess, which is always a good thing to clean gold contacts on the power switch here. And yeah, it basically looks as good as new. I'm putting some contact cleaner on each and every one of these as well. And there's a sheet of plastic here to insulate the rest of the circuit, which is also a nice touch. So cleaning this from the other side. I didn't want to take all the buttons out, which I don't think it's necessary really. Some alcohol on the switch contacts here. Pretty much the same construction that we had on the other calculator, just this little sliding part here. It's just a very tiny thing here. And that goes back into the slider. And then some contact cleaner on all the contacts. And I actually looked into my stash of screws here and I didn't find a matching replacement screw, so we are just going to use the old screw, I think. There's quite some pressure on that. And I'm turning these screws slightly counterclockwise before I put them in, so I don't strip the plastic threads, basically. For some reason there's one slightly longer screw that I don't know where it goes. Should have paid closer attention to that first time around. Ah yeah, that's the one. So next to the on-off switch there's a longer screw. All the other ones are the same. By the way, someone warned about getting alcohol too close to those bubble LED displays, so I'm not going to do that. I'm just going to use alcohol on these plastic parts. Maybe we need to put some hot glue in there to affix the display in place. So I'm just going to put this halfway back together here. Oh, we forgot the most important bit, which is of course the insulation. These were the cables from the original battery, no idea where that went. Probably somewhere like here. That's why this insulating sheet was in here. So I guess it's basically back together. We can, in theory, try this. Maybe it works, maybe it doesn't. We don't know. So I'm just going to double check my bench power supply. These clip leads on there, and I'm just going to set it up for 6 volts. And this is also current limiting, so we don't risk damaging our calculator too much. I am mildly excited. So the white one is the negative, and the blue one is the positive. So I'm plugging in. Fingers crossed that this is going to work. Plugged in. So I probably should have made the cables a bit longer, but this is going to do for now. Let's see. On. Yeah, there's a 0. Don't know if you can see that. Yeah, you can see a 1 now because it just typed 1. Clear. Wow, the keyboard or the buttons feel really nice on this one. How many digits do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 digits plus, I think, 2 exponential digits there. Nice. 45 divided by 5 is 9. It does still work. 1975 made calculator. 1975 made Commodore chips. Still working fine. Let's see if we can store something. That should be store. Okay, clear. Recall. Yep, that still works too. Function pi. That's pi for you. Yeah, this does seem to work fine. We don't have the rechargeable battery anymore, of course, but yeah, that's kind of useless anyway, because these consume quite a bit more power compared to today's calculators with LCD displays, of course, and running them from a battery doesn't really make sense these days, I guess. I guess what I'm going to end up doing is to just build a proper power supply for this. Maybe even in the original casing, and then use that. I love these digits here, they're so crisp. And the keyboards. And it takes a while for some operations, of course. So 1975 calculator taking sinus function. Takes 2 seconds or thereabouts. That's pretty cool. But it works. I didn't do the math, of course. Can use negative numbers, just like you would on a modern calculator. That is pretty cool. We can use the exponent. Oh, it reset again. Yeah, that's just my power supply thing situation here. I'm sorry. That is actually just my cabling. Yeah, we can use the EE function here to write something in the exponent position there. So this seems to fully work at this point. That's pretty cool. I'm going to take some care of the casing and just wipe this. The other part here, I'm probably just going to wash in the sink for a bit and then put it all back together. So I just decided that I want to put a dab of hot glue there where the old one was. This one here, which is still on my desk. I'm just going to put that in the corner there to hold the screen, the red screen, in place. And then we had this here, which probably covered these contacts. This was just stuck to this here, I guess. But this sheet of paper just exactly fits the width of these contacts here, so I suppose that's where that went. Maybe this is something to prevent this from trying to charge the battery. But the battery went on these 2 cables. That's pretty much definitively the case. That just broke off, which doesn't really matter. Yeah, I'm just going to cut this off a bit more, just so it doesn't interfere with anything. It's actually pretty impressive that these things still work. I mean, they were like, this is kind of a professional use model, but even the smaller one is still working fine without any issues. Cleaned this part in the kitchen sink just with some water and dish soap. Looks pretty much as good as new. These are not very good molds, but yeah, you can see some protruding bits there. But the plastic seems to be absolutely fine still, which is something you rarely see these days. It's really thick plastic as well. So they made stuff to last in those days. More civilized times. Yeah, I think I'm going to put this back here with some new masking tape. And I guess they did this in the factory actually to protect the contacts. That's actually what this was for. Don't want to tighten these too much. And I guess this whole portion just gets a bit of a wipe with a microfiber cloth and some window cleaner. So just some window cleaner on my microfiber cloth here. And this really basically looks as good as new, which is remarkable. There's a tiny amount of worn off paint here on this sinus thing, but I don't have any matching green paint at hand here. So I'm just going to leave that as is for now. And there's a tiny scratch in the center of the display, but otherwise this looks remarkably good after all those years. And of course this is worn out here, worn away by age, but the front side of this, the hero side, is in really excellent condition. And there you go. Completely working 1975 Commodore made calculator. And of course you can do all kinds of nice functions with this. That's squared, and we have the square root on the function key, which also works. Nice. Things like that. Really just useful, pretty much like a modern calculator. With 2 memory banks, we can use this to store in the second bank, and I'm just going to put something else in the first bank. Let's see if we can recall both of these. Recalling 2. Yup. Recalling 1. Sorry. That's 1. And that's 2. It works! Just a working calculator. And you can maybe see the little roughed up spot there. Could, in theory, polish that out, but it's not that much of an issue for me. Otherwise, it looks pretty much as good as new. This is the model SR6140R. R for rechargeable battery. From the Minuteman 76 series for 1976. Pretty cool. And the faux leather pouch, I'm just going to give that a quick wipe as well. Not much wear and tear on this. Just like it came from the factory. And this fits in here, we can close it up. And it's protected. Yeah, that's it for today. I'm really happy with my new old calculator. And thank you, Gert, again for sending me this. And it is going to get some use and some marveling. Thanks everybody for your time and for watching my videos. If you aren't subscribed to my channel yet, you should do so if you're interested in retro computer stuff and vintage electronics of all kinds, really. Thanks for your comments and your thumbs, and special thanks, as always, to everybody who supports me on Patreon and on Ko-fi and the YouTube channel memberships page and elsewhere. The links to that are in the video description. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye!